Thank you, Mr. Chairman. Dr. Collins, thank you and your colleagues for joining us today and for the work that you and your team across the country do. Let me start with Dr. Lowy. The President has proposed a pediatric cancer research initiative, safer treatments for children and better data. What can you tell me about the challenges we face in fighting cancer among children as compared to adults? Are there a sufficient number of children who are willing to participate in clinical trials? What are the issues that are unique to childhood cancers?
Thank you, Senator Moran. One of the most important things to understand is that children who have cancer are not just small people who have adult cancer, but childhood cancer is qualitatively different. Whereas adult cancer has many mutations, often there just are a few mutations that arise in children with cancer. In addition, while there's a tremendous amount of interest in cancer treatment for adult cancer, there is less involvement in the private sector, so that NCI has a particular obligation to do research in this area, and we have substantially increased the amount of research that we do in this area over the last few years. The particular proposal from the President is really along the lines of something that Senator Murray was asking about, which is how to efficiently and constructively aggregate data. And the goal, as we envision it, is to take pediatric cancer as an example where some of the information is still quite siloed. And by aggregating it and pulling it together with an interoperable system to be able to address important questions in pediatric cancer. Fortunately, in the terms of participation in clinical trials, a high percentage of children with cancer participate in that, and a lot of that is through the Children's Oncology Group sponsored by the National Cancer Institute. And because all childhood cancers are rare cancers, this is actually an international effort that is part of the COG.
Thank you very much. Dr. Hodes, we've recently seen a number of late-stage clinical trials focused on addressing Alzheimer's that have shut down, highlighting the difficulty in achieving meaningful progress in combating Alzheimer's. What is your view on the current state of Alzheimer's research? Where's the future potential? And maybe that's the questions.
Well, beginning with the failures in recent clinical trials, of course, all of us are deeply disappointed at them. And these are efforts that are generally been targeted at amyloid protein in individuals who already have symptoms. There are cases where there's very strong evidence to think that this amyloid pathway still may be important, in particular in some of the early onset familial cases, but also by targeting earlier in disease. And so we are pursuing those specific areas. But in addition, thanks very much to the increased funding that has come from Congress over past years, our understanding of the processes underlying Alzheimer's have improved enormously. Last year, for example, some 32 new genes were identified, more than had previously identified all around. This has led to the ability to identify from those genes, bioinformatics, systems biology, new targets. The number of targets is illustrated, Francis, if we actually have a visual to look at. This is meant to show at stages from drug discovery, drug development, to phase 1-2 trials and phase 3 trials. Starting at the left, the early stage of discovery, each of those bars represents a different kind of target currently under study. And you can see the number of targets, whether it's inflammation or protein trafficking or proteostasis, that we're discovering more and more about as potential avenues. So the more targets we approach, the greater the probability in individuals with particular syndromes that we're going to have success. Out of some 35 clinical trials now ongoing, 13 are targeting amyloid, the rest at this multitude of targets. So a new generation of investigators, new science is leading us to this multitude of opportunities to make sure we have the way paved for a multitude of approaches to Alzheimer's disease.
Dr. Collins, the new set of scientists, the next generation, I can't think of the young lady's name on your screen years ago, but you highlighted her as somebody we're going to lose because of the instability in research funding. And while I suppose we're always looking for the concrete evidence that the funds have resulted in a cure or a treatment, perhaps at between now and when we find all those cures and treatments, you can reassure me that the investment led by this subcommittee has made a difference in keeping, retaining, and encouraging young people to pursue careers in science and research.
Appreciate the question very much. Yeah, that was a young woman as a graduate student at MIT who was about ready to give up. That was a while ago. And look at this curve, which shows you our ability, thanks to you, to be able to ratchet up the awards that we've given to early stage investigators, that is, people who've not previously been a principal investigator on an NIH grant. In 2013, that was a little less than 600. Last year, we challenged all the institutes to try to really push this forward and get us to 1,100. We got to 1,287, by far the largest in history. We have made this a priority, and every one of those individuals represents somebody with a lot of energy, a lot of innovative ideas. This is the most important investment we could make.
Senator Shelby would have asked had he not run out of time, but on his behalf, I would ask if you would come to Kansas.
Yeah, thanks, Senator Moran.